Hi everyone, I'm Ariel and this is Raffa. Sadly today I'm a little bit under the weather, so I can't have the funny voices. You'll have to listen to my own voice, so at least you get to see my lovely face. So let's begin. We're going to continue our voyage through the model store. So where we left off is by noting that everything is a store, right? And we've done the feature store, and now we're doing the model store. So today we're going to explain in depth what it means and how to build one. And later on we'll actually build one. I've even made a comparison chart that we will see later, but it's not important right now. Why are we doing this? I'm doing this to reinforce a concept that I think you should be familiar with from areas that are not MLOps. That's like building stuff over very robust parts of your stack. We call it the MLOps Engine. It's open source, and that's how we built the feature store, and that's how we're going to build the model store. But wait, you're going to say, I know ClearML. You have something to do with models, right? Why are we building something else? Well, so models are indeed a very important part of ClearML because models are the most important thing in machine learning, because that's what you deploy eventually. And we do have a nice graphical UI with all the metadata tracking, but what we are actually giving out of the box is what I like to call an experiment-first approach, right? It's noting that the most complicated part in R&D is experiment tracking and reproducibility and orchestration and automation of thereof. And you've probably seen, if you've seen any of my webinars, you've seen this complicated picture, which just proves that in order to actually track everything, you need to collect a bunch of information that's not just the Git packages, and also save almost everything and eventually have it somewhere that you can serve it from. So that's experiment first, and it's really comfortable for data scientists, machine learning engineers to approach the situation. But if you're from DevOps and you want to be, let's say, serving first, that's the complete opposite. And a good compromise in the middle is what I like to call model first. So in model first, you have some kind of a promise. There's experiment tracking going on, and the tracking information is connected to the model in a certain way. So it's a promise, right? The data provenance and all the metrics from the training is tracked, and that's connected to the model. The labels and this tracking information are packed together with the model to form some kind of artifact, and that is secured somewhere that you're able to pull when you want to serve. And this little part of the chart is the model store, right? The model goes in, and there's some kind of user-friendly way to explore what you have there, and also it connects to serving. It's exactly what I've said last time. Actually, the giraffe said, right? It's like a contract that the model has all the reproducibility information and is able to do serving. So what's in the box, right? So any kind of metadata that your organization thinks is important to be carried on along with the model. The actual storage, it could be object storage, could be anything, a catalog that you can search and look at the status of the models, and as I said, a nice coupling to experiment tracking. In terms of serving, you need a way to do direct deployment from there of the artifact. You need to know which pre-processing to your data needs, and of course you need the code. So I won't touch on this today, but okay, we all know of these off-the-shelf model stores, these open source model stores that you can just install and use today. Why are we building one from scratch? Well, the main reason is that an off-the-shelf solution that tries to do something as diverse as I just described is bound to be highly opinionated, okay? So if it's trying to do things just the way you thought things are going to be, that's okay. There's no stress of integration, and you are able to roll. But most of the times, you would want something that's easy to change and fit to your own goals and own targets, own roadmaps, and that means you need something with less clutter. So sadly, there isn't any kind of like generic model store.ml that you can install. But even if there were, it would still be slightly opinionated. The closest I could find is from our dear friend Neal. It's under the moniker of Operator AI. It's an actual model store that is stripped down of all the unnecessary parts. Okay, there's even a substack describing it. Just go and follow it. I'll put a link in the details of this YouTube. And basically, Neal came up with this sentence I really like. When you're building something, first you approach it by narrowing down the problem space. So this job was done for me in this post, and that's what you get with this model store. It's a common interface over any kind of storage, any file system, GCP, AWS, whatever. So you can just say upload. All the serialization code, you need to store the model somehow, and every framework does it slightly different. So all of that is already in the box. And also offhand collection of the metadata about the runtime, dependencies, and right now, because this is a very, let's say, a fresh package, it's just printed out on the screen. It's not stored anywhere. But this seems like something that we should build, and the proof is in the details. Actually, if you look at code that's from their example, it's exactly what you would expect from a stripped down version that's easy to build and easy to extend to your own needs. Okay, so first you have some kind of training pipeline. You as an R&D person, you supply it, or if you're not in R&D, the R&D gives you the training pipeline. And then when the pipeline ends, you have a model. The model store has a method that is here library specific that uploads the model. And on the way, here's the opinionated part, it collects the metadata that it thinks should be added. If you want to extend it, you can inherit from this method, you can do whatever you want. But it has some kind of opinion on what's the metadata to store for every kind of model. For sklearn, scikit-learn, it's different than other ones. Eventually, this is the right idea. You finish the upload, you create a report on what you just uploaded, and you track it also. So you can convey what's in the model when you're trying to understand which model should go where. First of all, kudos on this library. It's really nice. And so let's compare them. I think now I have to remove my image. Okay, so I split it down to three parts. It's the metadata creation, it's the packing and store aspect. It's not storage, it's the store as in shop, right? So labels are something that you define. It's from the R&D, and it's stored by the model store automatically. In ClearML, it's automatically only under specific frameworks, but you can do it. It's very easy, and I will show it in the next episode, but it's not per se opinionated. Packages, Git, whatever, you know that ClearML has it. It's, I think, so easy. Just add 2 lines to your code and everything is tracked. As I said, model store has it. It's some kind of print, but it probably will be better with time. Extra metadata. Well, as you probably have your own idea on what kind of metadata you need with your model. If it's your dataset internal ID, if it's your accuracy, precision metrics, model store does something. ClearML doesn't do anything, but you can add whatever you want, and we'll see that next episode. Packaging. Okay, in R&D, you would serialize the model the way you want it to. That will fit your serving logic. Model store does a pretty good idea, a pretty good job. In ClearML, we do exactly what the frameworks do, right? If you're using scikit-learn, you're probably using joblib, so you don't even have to add a single line of code. ClearML will recognize this and will serialize the model for you. Same for Keras, PyTorch, TensorFlow, XGBoost and whatnot. But still, it's not as automatic as you would want if you have special needs. For example, if Hugging Face changes what they have in transformers, this is something that will take maybe 1 or 2 releases to get updated, both in these 2 libraries. But since Model Store is, I guess, smaller, it's easier to fix on your own. But still, it's something that probably, if you're using cutting-edge releases, something that you should be doing with R&D anyways. Okay, metadata. Both packages handle it very well. In ClearML, you can add extra files to your model and just declare it as a package. And uploads is, I think, handled very well in both methods. In ClearML, you also get, if you're using ClearML free, you also get free cloud storage, 100 gigabytes to store your models. Some of the times, I guess most of the times, this will happen actually automatically. And we will see that we don't have to write explicit code for that in ClearML, but in Model Store, you just have to create the Model Store and save it. In that sense, Model Store is much simpler because it creates a very ordered, simple file structure on your Model Store, so you're able to just explore it on your, if it's S3, so on your S3 Explorer. But in ClearML, it's, as you see, you have the UI. And we go directly to the store aspect with this. So, as we said in the beginning, you would want to create some kind of report. So in Model Store right now, it's just simple text. In ClearML, you can do almost everything, and you have examples in our site. And you attach it to this task that trained the model, and you can directly approach it from the model itself. Search, well, search is pretty awesome in ClearML. In Model Store, it's probably going to be released maybe this year, maybe next year. GUI, same thing. You saw the GUI, and you can log in today for free to ClearML and see it on yourself. And connection with serving, I guess this is very important in terms of R&D. You have to make sure that if you're building a model and you're trying to save the stripped down version, for example, weights as the model, so you have to pass on the code that creates the model, maybe a config file, a prototext, whatever. In Model Store, it's done externally. And in ClearML, it's done using ClearML serving, which I will have a different video altogether on that, but it's awesome as well. Okay, so I guess I'm done talking. Next time, we will actually look at the right column and try to recreate this very simple looking code snippet we saw with ClearML. And as you're gonna guess, it's gonna be almost similar, if not even less. So I guess you'll be expecting that next week. So like this video, dislike it if you didn't like it, subscribe, let me know what you thought about it in the comments. You got the deal, and thank you for listening.